Okay, welcome everyone. This is 11.2 on ellipses. So an ellipse is a set of all points in a plane that the sum of whose distance from two fixed points, there's two foci or focuses. Okay, these fixed points are called foci, plural of focus of ellipse. So wherever it's just an oval, guys. Okay. Just a lot of math words for it's an oval that we're graphing. Okay. And every single point on this, they're going to be equal in distance, right? So we are going to learn how to graph this based off of this information here. Okay. So the equation of an ellipse, it's the key points to, you guys can look at the equation. The key points here to remember is that it's always going to equal 1. Okay, that's the first thing. It's always going to equal 1. And we are going to be adding x squared plus y squared, okay, equals 1. And whatever your denominator is, that's your a squared and your b squared. Okay. And your vertices, whatever one's bigger. So if here, in this case, here, my A is always going to be bigger than my B, right? If the number below the x squared is bigger, then it's going to make a horizontal oval like this. Okay? All right? If your y squared, or if your A value, if the value of the number below or underneath the y squared is bigger, right, than your x squared, then it's going to be a vertical oval like this. That makes sense? Yeah. So just follow the numbers. I honestly did not memorize what my A, my B values are. I just know it's going to be, the A is always bigger. Okay, so if your A is always bigger and it's underneath the X, it's going to be a horizontal ellipse. Okay. And if your A is the denominator of y squared, it's going to be a vertical ellipse. All right. So wherever your vertices are, that's going to be your major axis. Okay. And the length of that, we're talking about this as our major axis here. Okay. And this as my major axis here. And my minor axis is here and here. And that's always going to equal 2b, because from here to here is b, and from here to here is b. Okay? And my major axis here to here is a, and here to here is a as well. So we can see that that's going to be 2a. Okay? And you guys have to know how to get your foci. That's always going to be c squared equals a squared minus b squared. So your bigger number minus squared minus your smaller number squared. All right? Okay, and we're going to learn how to graph this given an equation. Cool? All right, so let's get to graphing. Let's first match this up. Okay, so the first thing you do when we're matching, you notice that your everything here for number 5, it equals 1. So that's the first thing you check. It has to equal 1. If it doesn't, you have to divide it by that number. Okay, so for number 7, we're going to divide it by 4, right? Divide it by 4, divide it by 4. So x squared over 1 plus y squared over 4 equals 1. Make it equal to 1. All right? That's your first step. Okay, and number 8, we're going to divide it by 400 when we get there. But you see number 5, going back to number 5, x squared, the denominator of x squared is 16. The denominator of y squared is 4. Since 16 is greater than 4, yeah, it's going to be a horizontal ellipse because the x squared has a bigger number as my denominator. So it's going to be a fat one, right? Yeah. Does that make sense? Okay. So your vertice will always be that number square rooted. So my A value here is 4. My B value here is 2. Okay? Does that make sense? Square root of 16 is 4. Square root of 4 is 2. Right? I mean, I can give you guys this step as well. Okay? So we have that at 4 and 2. 1, 2, 3, 4. Negative 4 and positive 4. Positive 2 and negative 2. Yeah? So this, number 5, the answer would be 2. Okay? So your vertices are plus or minus 4, 0. Okay? Just to list out all the information here. Vertice is 4 plus or minus 4, 0. The length, no, actually, let's get the foci first. The foci will always be c squared equals a squared minus b squared. So that's c squared equals 16 minus 4, which is square root of 12, which is equal to 2 square root of 3, which if you use your calculator, 2 square root of 3 is 3.4, right? So it's approximately 3.5. So if I were to graph this, I would graph these points first, right? And then my foci is 3.5. So it's like right here. 1, 2, 3.5. That's my foci. That's my vertex. And that's my foci. That make sense? Yeah. Okay. Yeah. How do you know if it's vertical or horizontal? You look at the number that's, you look at the denominator, and whenever one's bigger, if it's underneath the y, it's going to be horizontal because that's the y-axis. If it's the x-axis that's bigger, then it's... So since 16 is greater than 4, and 16 is underneath x squared, right? It's going to be fat and not lean. Okay. Number 6, x squared plus y squared over 9 equals 1. If it's just x squared, it's always going to be over 1. Okay. So y squared over 9 is greater than 1. So it's going to be a long one. It's going to be a vertical ellipse. Correct? Okay, where my A value is 3, my B value is 1. So here, just look for 3 and 1. It's number 4. Yeah? Does that make sense? Because I got positive 3 and negative 3, negative 1 and positive 1. Okay? So this one is 4. For number 7, it's going to be another vertical ellipse where my A value is 2, my B value is 1. Just looking for that. That's number 1, right? Positive 2, negative 2, positive 1, negative 1. So it's just 1. So number 8 has to be number 3. But if you divide, we're going to divide this by 400, right, to make that side equal to 1. Okay? When I divide this by 400, this becomes 25. Y squared over 16 equals 1. Okay, you always have to make the right-hand side equal to 1. All right? So if it equals 1, and it's x squared over 25, my A value is 5, my B value is 4. So you just look for 5 and 4, which is number 3. Yeah. 1, 2, 3, 4. 1, 2, 3, negative 4. 1, 2, 3, 4, 5. Right? And this is positive 5. Cool? And we'll do more of the get the foci and get the length of everything here or below. Okay? The next thing is eccentricity. Okay? It's how elastic this oval is. So the more it looks like a circle, it's close to 0. There's no elasticity, right? The wider it goes, either horizontally or vertically, the greater the elasticity is, right? So how we get that is just this number. E equals C over A. All right? And this number will always be between 0 and 1. Okay? All right? It will always be between 0 and 1. And it's just how elastic it is. Eccentricity. Okay? Cool. Now with that all in mind, let's find this. Okay? The equation is given, and then we're gonna find the vertices, the foci, the eccentricity, determine the lengths of the major and minor arcs or axis, and sketch the graph. Okay? So let's do number 11. we have x squared over 36 plus y squared over 81 equals 1, right? And we have to find the vertices, the foci, the eccentricity, and the length of the major axis and the minor axis. Okay. So the first thing is this a tall one or a fat one? Tall one, right? Yeah, because the number below the y squared is bigger than the number below the x squared. Okay. So my A value here is 9. My B value here is 6. And I got 9 because that's the square root of 81. I got 6 because that's the square root of 36. Okay. Vertices will always lie on the major arc. So this is going to be plus or minus 9, or plus or minus, nope, not plus or minus, 0, comma, plus or minus 9. Okay. To get my foci, I need my C value. Remember, C squared equals A squared plus B squared, or minus B squared. So C squared equals 81 minus 36. Okay. So that's 45. So C is going to be the square root of 45. And you can put that as 3 square root of 5. Okay. And since we're going to have to graph it, I want that C number in a decimal. So square root of 45 is approximately 6.7. Okay. All right. So we got all this information. So the foci will be 0, comma, plus or minus 6.7 because the foci will always lie on the major axis as well. Okay. The eccentricity is going to be C over A, which is 6.7 over 9. If you do that on your calculator, you're going to get approximately 0.745. Okay. The length of the major axis. So it's going to be 2 times the bigger number. Okay, and the minor axis, it will always be 2 times A, and your minor axis will always be 2 times B. So 2 times 9 equals 18, and the minor axis is 2 times 6, which equals 12. So I got all of that, right? I did A and B. Now we just have to graph it. Any questions here? No? So when we graph it, since it's 9 and 6 that I have to go to, I'm going to make everyone equal to 3. So that's -3, that's +3, that's 3, and that's -3. Okay, each unit going to equal 3 units. Okay, so my vertex is 0, comma, plus or minus 9. 1, 3, 6, 9. Let's go 3 units up, 3 units down, 2 units to the left, and 2 units to the right. And here is my ellipse. Okay. And just try your best. If I can't get it perfect on this program, then by hand, you're not going to get it perfect as well. Okay. Yeah, just try your best to make it as close as possible. And make sure that your points are easily seen. Okay. Because when someone grades this, they're going to look for those points. All right. And your foci is 6.7, right? So 3, 6.7 is a little bit here. That's your foci. And then that's it. And we're good. That makes sense? Questions on this? And if you want, you guys can graph it first and then get your length of your major axis and your minor axis. Okay? Because once you guys get these points, the first points that we talked about, right? This point, this point, this point, and this point. Now you guys can visualize it and how the ellipse is going to go. And your major axis will always be bigger, right? Longer than your minor axis. Okay, so then you guys can actually literally count, right? 3, 6, 9, 12, 15, 18, right? And then 3, 6, 9, 12. Okay. We can do that as well. Cool. Let's try number 15. Okay. 9x squared plus 4y squared equals, no, let's try number 16. 4x squared plus 25y squared equals 100. I gotta add 2 more pages. Okay. So here we have 4x squared plus 25y squared. I'm sorry, I want to do number 15. I apologize. 9x squared 4y squared equals 36. This is number 15. So we need our vertex, our foci, eccentricity, our major axis, and our minor axis, right? Okay, so we first look at our right-hand side, and we notice that it does not equal 1. So in order to make it equal to 1, we got to divide by 36. Divide by 36 and divide by 36. So this would be x squared over 4 plus y squared over 9 equals 1. Correct? Okay. So again, since my y squared is bigger, my a value is going to be square root of 9, which is 3. My b value is square root of 4, which is 2. So my vertex or my vertices are going to be 0, comma, plus or minus 3. Right? Make sense? Yeah. Okay. To get my c value for my foci, c squared equals a squared minus b squared. So that's 9 minus 2, or 9 minus 4, which is 5. So that's going to be c equals square root of 5. So that's going to be 2.23, 2.24. Okay. Approximately 2.24. So my foci is 0, comma, plus or minus 2.24. My eccentricity is c over a. So it's 2.24 over 3, which is 7.45 or 0.745. Okay. My major arc is just 2 times my a value, which is 6. My minor arc is going to be 4. Okay. So we got all the information, right? And now graphing this, major arc is, or my vertices are 3 and -3, and then 2 and -2, or -2 and 2, and draw the ellipse as well as you can. Okay. Thank you. My foci is 0, comma 2.24. So 1, 2.24, just a little bit. 1, 2, and just a little bit. Cool? Questions? So make sure you guys remember parabolas only have one variable squared. That's how you know that it's a parabola, right? Because I'm going to throw a bunch of equations at you, and you guys just have to graph it, right? Does that make sense? That's going to be your assessment, okay? Your test. I don't know, okay? I'm going to throw it at you, and you have to notice, okay, I only have one variable squared, so that has to be a parabola. In this case, both variables are squared, and there's a plus sign, right, in between it. So I'm going to have it. That's an ellipse. Hyperbolas, the difference is there's going to be a minus. Okay, it's going to be the same thing, but it's going to be a minus. Okay, and the steps to graphing are a little bit different. That makes sense? Yeah. So those key things you guys have to kind of remember and make sure that you guys understand that. Okay. So here I'm going to do one of these and then do one of these. Okay. Find an equation for the ellipse whose graph is shown. So you're going to have a graph and you're going to gonna have to be able to find the equation. Okay, so I know that this is an ellipse. So I know the general form of an ellipse is x squared over, I don't know if it's a or b, plus y squared over equals 1. This one for number 29, it's a fat one, right? It's a horizontal ellipse. So underneath my x squared is a, underneath my y squared is b, right? Because my a value will always be bigger than my b value. What is my a value? Well, this point here is at 5. This point here is at 4. So that's my a and my b value, right? So this one is just x squared over 5 squared plus y squared over 4 squared equals 1. And I don't have to talk about 5 squared being equal to 25 and 4 squared being equal to 16. And that is my equation. Yeah. Okay. Make sense? No? I might ask for the extra information, like what's your foci and stuff, but you can figure it out from here, right? Here, class, we have our foci point, right? And here we have our b value at 2. So since I know it's a vertical ellipse, x squared over b squared plus y squared over a squared equals 1. And I also need to know c squared equals a squared minus b squared, right? And we're just going to plug in our values. I know here my foci is at 2, so my c equals 2, right? Because it's going to be plus or minus c from my foci. And my b value here is also 2, right? So going to my second equation, c squared equals a squared minus b squared. 2 squared equals a squared minus 2 squared. 4 equals a squared minus 4. Add 4 to both sides. My a squared value is 8. I don't care about my a value. I just care about my a squared value because that's what I need for my equation. So x squared over 4 plus y squared over 8 equals 1. That's it. Questions on these problems? On how we got them? Cool. That's the lesson for today, class. Thank you very much.